In 2.7, we're going to talk about arithmetic sequences. So I want you to look at the bottom of the page, on page 146, at the got it problem. Letter A, the sequence 5, 11, 17, and 23. Describe a pattern in each sequence. What are the next two terms of this sequence? So this should be really easy. The pattern from one to the next is plus 6. So, if our pattern is plus 6, the next two terms of the sequence would be 29, and 29 plus 6 gives us 35. Now we look at letter B, 400, 200, 100, and 50. Well, what happens from 400 to 200? We subtract 200. Now, if you do use that pattern, you'll notice, well, 200 to 100 is not subtracting 200. So we are not going to be using that same pattern of subtracting 200. So let's look at 400 to 200. 400 to 200, what else could I do? You could divide by 2, or you could multiply by a half. Okay? 200 to 100, does that work? Multiply by a half, which is divide by 2. Multiply by a half. Absolutely, that is our pattern. So if we multiply by a half 2 more times, 50 times a half, or a half of 50, is 25. A half of 25 is 12 and a half. So our next two terms will be 25 and 12 and a half. Now look at the box in the middle of the page. It says your essential understanding. When you can identify a pattern in a sequence, you can use it to extend the sequence. You can also model some sequences with a function rule that you can use to find any term of a sequence, and that's what we're going to start doing, is using a function rule. Now your vocab, a sequence is an ordered list of numbers that often form a pattern. Each number in the list is called the term of the sequence. I want you to look at C and see if you can figure out the pattern yourself. So if we're going from 2 to negative 4, and 8, and then negative 4 to 8, and then 8 to negative 16, you will find that each time you are multiplying the previous term by negative 2. So our next two terms would be negative 16 times negative 2, which is 32, and 32 times negative 2, which is negative 64. Now I want you to look at the box on the top of page 148. In an arithmetic sequence, the difference between the consecutive terms is a constant. The difference is called the common difference. Make sure you understand what common difference is. We are going to be using the common difference in a formula later on. So now we're talking not just about sequences, but an arithmetic sequence. So let's look at the got it problems, A, B, C, and D. So let's look at A. Tell whether the sequence is arithmetic. If it is, what is the common difference? So if we look at letter A, 8 to 15 we add 7. 15 to 22 we add 7. But then we add 8, so you have to check all the terms. Therefore, A is not an arithmetic sequence. B, 7 plus 2, 9 plus 2 is 11, 11 plus 13 is 2. There's a difference of 2. So we are adding 2 each time, which does make this an arithmetic sequence. So here's what you need to know, the common difference. The common difference is 2. Let's look at letter C. Letter C, we're going from 10 to 4. We are subtracting 6. We're subtracting 6 to go from 4 to negative 2, and we are subtracting 6 again to go from negative 2 to negative 8. Therefore, yes, it is an arithmetic sequence, and our common difference would be negative 6. And lastly, 2 to negative 2. Well, we could say we subtract 4. Well, that doesn't work because then we'd add 4 again. But really what's happening is you're timesing each of these by -1. Therefore, this is not an arithmetic sequence because you're not adding or subtracting. Therefore, this one is not an arithmetic sequence. Now I want you to look on page 149 at the big gray box at the top. This, I want you to make sure you understand this clearly because this is how a function is written. So let's start reading it. A sequence is a function whose domain is the natural numbers. So remember domain. Domain is what you plug in. That is your x values. So that means the numbers of our x values are 1, 2, 3, 4, and so on. The outputs are the terms of the sequence. You can write a sequence using a recursive formula. This is your vocab word. A recursive formula is a function rule that relates each term of the sequence after the first to the ones before it. Consider the sequence 7, 11, 15, and 19. You can use the common difference of the terms of an arithmetic sequence to write a recursive formula for the sequence. For the sequence 7, 11, 15, and 19, we are adding by 4 each time. Therefore, the common difference is 4. So here is how your sequence works. N represents the term number in the sequence. What that means is like it's the first number in the sequence, the second number of the sequence, the third number in the sequence. Now, A of n, A of m, is the value of the nth term. So that would be the value of, let's say, the fourth term in the sequence. So I'm asking for your range, your output. So n is your input, A of n is your output. So if you look where it says value of term 1, well, if you look at our sequence that we had, which is 7, 11, 15, and 19, the value of term 1, now this means A of 1, that means n is 1. N is 1, which means the 1 is the first term in the sequence. A of n is what the value of that is. So the first term of the sequence is here. So what's the value of the first term? It is 7. Now the value of term 2 is going to be A of 2. Now, this is where it gets a little confusing. To get that, we have to take A of 1. Now, A of 1 is the term before that. And then we add the common difference, which is 4. So that would be 11. So the value of A of 2 is 11. A of 3, we would take A of 2, which is the previous term, and add 4. That gives me 15. Then I do A of 4. So I take the previous term, which was A of 3. Now, A of 3 was 15, so I add 4, and that gives me 19. So here is how you write your rule. A of n. So what you are going to do is you would take A of n minus 1. Now this is where you got to think. A of n is the term of the sequence that we're on. A of n minus 1 would be 1 less than that term. So we take the term before it. That's how you get this. A of 4 would be 4 minus 1. This is the term before the fourth term. So whatever term this is the term before it. And then the common difference is 4. So the arithmetic sequence is this formula. But we also have to state what the first term is, so we know what we start with. So we have to say where A of 1 equals 7. That means the first term in our sequence is 7, and then we know from this formula that we add 4 each time. So this would be the recursive formula for the arithmetic sequence shown above. So now I want you to look at the bottom of page 149. We're going to do the got it problems. So, letter A, 3, 9, 15, 21. Let's find what we're doing here. So we add 6, add 6, add 6. So we know each time we're adding 6. So we have to write a recursive formula for each arithmetic sequence. And then we have to find the 9th term of the sequence. So the first thing I want you to do is just tell me what the first term of the sequence is. The first term of the sequence is 3. So if you remember, n would be 1, and A of n would be 3. So this is how we write it. a of the first term of the sequence equals 3. We have to identify where our sequence starts. Now, we're going to put a of n, this is going to be the same for everything, equals the term before it, which is n minus 1, a of n minus 1. Then we have to identify the common difference. Well, the common difference is plus 6, so I put a plus 6 at the end, and that is my answer. But then I have to figure out what the 9th term is. So in order to find the 9th term, we're going to do a of 9. You just basically keep going your pattern. We have the 4th term right here, so add 6 until you get to the 9th term, and you will realize the 9th term is going to be 51. So we can say a of 9 is 51. So let's try b. Start with our first term. Our first term is 23. So now we need to see what's happening. So we add, here we add 12. We add 12. We add 12. So we know our common difference is 12. So we're going to write a of n equals a of the term before it, m minus 1, plus our common difference, which is 12. So there's our answer. And we need to find the 9th term. So if you follow your pattern, the 9th term was going to be 119. And the last one. What are we doing to each of these? You are adding a half, or 5/10. So we start with our first term, which is a of n equals 7.3. And then in our formula, a of n equals a of n minus 1 plus our common difference, which is 5/10 or 1/2. And then we know our 9th term would be, whoops, not 25. I looked at the wrong problem. Your common difference would be 11.3. And there's your answer. Now look at the problem, the key concept, at the bottom of page 150. The gray box above it says, you can find the value of any term of an arithmetic sequence using a recursive formula. You can also write a sequence using an explicit formula. An explicit formula is a function rule that relates each term of the sequence to the term number. So here's your key concept. The nth term of the sequence, with the first term a of 1 and the common difference d is given. So you'd have a of n, which is your nth term, equals a of 1, which obviously is your first term, plus your term number, n minus 1, times the common difference. So let's see if we can use that. Let's look at problem 4, the got it problem, letter A. It says a subway pass has a starting value of $100. After one ride, the value of the pass is $98.25. After 2 rides, its value is $96.50. After 3 rides, the value is $94.75. Write an explicit formula to represent the remaining value on the card as an arithmetic sequence. What is the value of the pass after 15 rides? So first, I'm going to write this as a sequence. Your sequence does not start with 100, and that's a common misconception because it says the subway pass starts with $100. But the first term of the sequence is not 100. It says after one ride, the value is $98.25. Therefore, the first term of the sequence, which is one ride, is $98.25. The next term of the sequence, after 2 rides, it's $96.50. And then we have our third ride, which is $94.75. If you look at what's happening here, you're subtracting $1.75 each time. So that means our common difference, which is D, is negative $1.75. So if we plug that into our formula, we're just going to write A of n. N stays the same. You don't plug anything in for n. The first term of the sequence, well, the first term of the sequence, A of 1, is $98.25. Then we add, in parentheses, n minus 1, and then our common difference is times negative $1.75. You can leave that as your sequence, but I'd rather you not, because I would rather you simplify it. So then we have A of n equals $98.25. Distribute the negative $1.75 plus $1.75. Combine like terms. A of n equals, and that gives us $100 minus $1.75 per ride. So that is our formula as an explicit formula for the arithmetic sequence. Then it says, what is the value after 15 rides? So n is the number of rides. All I do is plug it in. I take 15 times $1.75 or negative $1.75, and then you take 100 minus that value, and then you would get what's left on the card, which is $73.75. So our two answers would be this and the $73.75. B says, how many rides can be taken with a $100 pass? So we have a $100 pass. So how many total rides can be taken? So think about what you need to do. So in order to find out how many rides can be taken to use all $100, we want $0 left. So I'm going to plug in 0 right here. So 0 equals 100 minus $1.75m. I subtract 100. I divide by negative $1.75. You're going to get approximately 57 point something. So how many total rides? Well, you can't have 57.1 rides. So you would be empty, or you would use your pass after 57 rides. The next two things I'm going to go over is how you can write an explicit formula from a recursive formula and vice versa. The first thing I want you to understand is an explicit formula is one where it tells you the beginning number and then the difference from everyone after that. So you actually can write your own sequence based on the explicit formula. A recursive formula is something where it tells you the pattern, but it also tells you the first term. So it's like two separate things. So let's do the next example. On problem, the got it problem on A, under problem 5 on page 152. So here's problem A. Now notice that we are given the common difference here, which is plus 2. So you take the previous term and add 2, and then it tells us the first term. Now let's review what the explicit formula is. This should be really easy because all we need to know here is A of 1, which is our first term, and D, which is our common difference. So all we do is look here and realize this is our common difference. This goes in where D is. This is our first term, A of 1. That's going to plug in there. So in this problem, all we're going to have is A of n equals our first term, which is 21, plus our common difference, which is 2. If you would like and distribute the 2 and combine like terms, you could also do that. But all you would have is A of n equals 21 plus, in parentheses, n minus 1 times 2. So I want you to try letter B on your own. And letter B would give you this. A of n equals 2 plus, in parentheses, n minus 1 times 7. Now we're actually going to be writing a recursive formula from an explicit formula. So once again, this is our first term, this is our common difference. So all I do is go backwards. You would take A of 1, which is telling us our first term. So we're going to say our first term is what? 76. Now we use the formula, and we say A of n equals A of n minus 1, and then we take the common difference, and it goes here, plus 10. So try number B or letter B on your own, and then pause the video, and then see if you got it right. Here's what the answer would have been. a of 1 equals 1, and then a of n equals a of n minus 1 plus 3. The plus 3 is our common difference that goes out front, and our first term is 1.